Good evening, everyone. Here I am again. My name is Georgie Palahang. So today we will discuss the different evaluation of different programming languages. So for us to differentiate between different programming languages on their interpretation or evaluation techniques, we have a sample code here. So for us to understand it in different programming languages evaluation, first let's understand what we're trying to achieve. So here we have a function, a main, which is defines variable I, j, and sum1 and sum2. Sum1 is basically I divided by 2 plus a function, which a result of a function, which is whatever value it receives plus 4 returns the value again k, which is whatever value received as k plus 4 plus, and then it will be multiplied by 3 minus 1. And then here we have function, which is a function which is doing the same calculation plus j1 j divided by 2. Okay, so here I made a code for C and C++ and Java and C Sharp. So as you can see here, you can see the totally different evaluation with the same code understanding, which is leads to different outcome. So I will explain to you why the result differentiate between programming languages to the programming languages. Okay. So I'll go jump directly to C++ because C and C++ are almost the same function. So here I have the same method that we have earlier, which has a function whatever k value plus 4, and then it returns 3 whatever it will be the new value of k, which is plus 4 minus 1. So you can see here in the main functions we have the definition of variable int I equals to 10, j is equal to 10, and sum 1 and sum 2. So we have here I as a 10, so it will be 10 divided by 2 plus the result of a function which value pass the value of 10 plus 4 and returns it to so 10 plus 4 equals to 14. 14 times 3 following the MDAS sequence. So multiplication first. So 14 times 3 equals to 42 minus 1. So the expected result will be 41. But as you can see here, the only difference when we're getting the value of summation 1 and summation 2 with the same value is the order when the function was called. Okay, so you see here I was debugging earlier and comparing the result and just to making sure that we are on the right track. So for the sum one, for the first sum, I was running the other one, but anyhow, it's the same code. So see here we have, I'll comment this one and run in C++. Console. See, yeah, here is now the result. The question is why there is a difference with the result of sum 1 and sum 2 even though they have the same value as an input parameter. Here in C++, we are passing the reference of a variable. So here, we are not doing anything, or in this reference, we are passing 10 divided by 2, which is 5 plus 10. So here, there is no change on the reference of I. Okay? I remains 10 plus 4 equals 14. So 14 times 3 equals 42 minus 1, then it returns the value of 41. plus the remaining 5. That's why if you convert it in the mathematical expression, it will be 5 plus 41, which is resulting to 46, which is our value here in first summation. And the summation 2, if you can see here, we're calling the function first. So the value of j, when it was passed, it was 10, right? So 10 plus 4. Remember, we are passing the reference of the variable. So it means it is in the same memory location. So we're changing the value on the same memory location. So take note, the original value is 10. But when it called the function, it changed to 14. Right? So 14, then it will do the same operation. So 14 times 3 equals 42 minus 1. Then it returns the value of 41. But if you notice, the second order mathematical expression is j minus 2. Remember, what is our new value of j? So j is modified now to 14, right? So if you say 14 divided by 2, it is equal now to, what is the first result of the expression? Is 41 plus 14 divided by 2 is 7. So you can see now the result is 48. So that is the difference between C++, where it is touching directly the variable reference. We're passing directly the variable reference and change the value. But on the later, in other programming languages, if you can see here, I created a dummy in Java, a basic also in Java. If you can see here in Java, run Java. Why is there any error? I don't see any error. Let me comment it out here. Okay, sorry. It's not valid. I just change Java. I think it doesn't allow me create. Sorry. Usually I'm using a kebab case, but yeah, Java is a bit sensitive on the naming convention. So here, it's the same definition and the same execution with the same summation. In C++, in summation 1, we divide first and then we get the result of a function, which is the same operation. And function j plus j divided by 2. So as you can see, I'm just printing out the result. So in any other sequence or order of operation, it's returning the same result. Why? It's because in Java, we are passing a copy value when you're handling a primitive data type. You can do and mimic the same operation, how C++ behaves, passing the reference by defining a variable or a class who holds memory stored in a memory reference and pass the reference to an argument. So by default in Java, if you're passing a primitive data type, it sends a copy of the value. It doesn't pass a reference value. If you can see here in the line, if you can see here, we are doing the same operation. The precedents are not the same, But since we're passing not a reference, we are passing a copy value, so it doesn't change the entire execution. The value of the ing remains the same value throughout the operation. That's why it doesn't change. Unlike in C++ and C, we are passing, by default, we are passing a memory address. The question is, can we do it in Java? Yes, we can do it. Okay? How to do it? So first, we need to have an object. We'll instantiate that object. Will that will be allocated in a memory address. And when we pass an object, not a primitive data type, for example, I created an int reference has a property of value, and I created here, see here, yeah, see, I created an object int reference, a variable name a, and I set the value by 10, and then I say change. I'll say initial value, and then here my after change value. So that you can see the difference. Okay, if you run this program, see here the initial value is 10 and the after change value is 15. Why? As I mentioned, we are referencing, when we define an object or instance of an object, we are storing it in a memory address, and that will be used throughout the execution. Okay, so this is the when most of most programmers using the singleton pattern. So it means when object is defined, it will never be changed, and it will be it will never be you cannot have multiple instances of these objects. That is singleton. That's why when you define that manager or executor, it will be remain throughout the same process, and you can change the value along the way as your program execution. As you see here, I have a value, int reference has a value of 10, so the initial value is 10. But when I call the function called change, which is I said, okay, plus 5, when I print again with the same instance of my variable, it changed now to 15. Why? The difference is if you're passing as an argument as an object reference, it will pass the memory address. But if you're using a data type, it is passing a value or a copy of value of your variable. Okay, that's all. Thank you so much.